In this video, we're going to give examples and explain concepts and terms related to linear modeling from Unit 9b. What does it mean to say that a function is linear? It means that a function has a straight line graph. It means that the function has a constant rate of change. And it means that the function can be described by an equation in the form of y equals mx plus b. Define rate of change and describe how a rate of change is stated in words, that is, using with respect to. So the rate of change is equal to the slope of the graph. The rate of change equals the slope is equal to the change in the dependent variable divided by the change in the independent variable. And a rate of change is a rate that describes how one quantity changes with respect to another quantity. So that is D. How is the rate of change of a linear function related to the slope of the graph? The smaller the rate of change, the shallower the graph. The greater the rate of change, the steeper the graph. How do you find the change in the dependent variable given the change in the independent variable and give an example? The rate of change rule allows for the calculation of the change in the dependent variable from the change in the independent variable. Change in dependent variable is equal to rate of change times change in independent variable. For example, if the rate of change is 2, the expression for the dependent variable is change in dependent variable is equal to 2 times the change in the independent variable. It's A. So what they're saying here is if I have y2 minus y1 over x2 minus x1 equals my slope, but I can rewrite that as y2 minus y1 equals m times x2 minus x1. And this equation here is called my point slope form of my line. If I only have one point here, y minus y1 equals m times x minus x1. I think that's the point in trying to get you to multiply by the denominator there, is to get you used to seeing this form of the line. Usually we talk about things in slope-intercept form, y equals mx plus b, but sometimes it's necessary to write the equation of a line given the slope, the rate of change, and one point on the line. If we solve for y here, we'll get to the place of y equals mx plus b if we solve this equation for y. All right. Describe the general equation for a linear function. How is it related to the standard algebraic form of y equals mx plus b? And we just talked about that. The general equation for a linear function is dependent variable equals initial value plus rate of change times independent variable. So, and in the standard algebraic form of a linear function, y is the dependent variable, x is the independent variable, m is the rate of change, and b is the initial value. So it's very close to this. It's just that the order of, instead of saying mx plus b, they would say b plus mx basically, but it's just a little bit further away from this form that I started off with a second ago, the point slope form. So and describe the procedure for creating the equation of a linear function from 2 data points and how are such models useful. So let x be the independent variable and y be the dependent variable. find the change in each variable between the two given points, and use these changes to calculate the slope or rate of change. That's what I wrote up here. Find the slope first, then use either of the points, substitute the slope and the numerical value of x and y from either point into the equation y equals mx plus b, or you can use this other form that I gave you, but this works as well. If you plug x and y into y equals mx plus b, then you can solve for the y-intercept b, because there'll be the only unknown in the equation. And now use the slope and the y-intercept to write the equation of the linear function in the form of y equals mx plus b. So that's how they want to tell you to do it here. But I've shown you another way using the point slope of the form of the line. And if you set it up there and use your algebra techniques to solve for y, you'll also get the point slope form of the line. How are such models useful? The rate of change and the initial value can be determined from the model. Right, that's it for this video, and we will come back next time and keep talking about Unit 9B. See you for the next video.